The purpose of today's lesson is to recognize reflection and to reflect the figure in the coordinate plane. If you recall, the topic that we're dealing with is transformations. And what we're talking about is when we transform a geometric figure, whether it's in the coordinate plane or not, we are changing the size, location, or both of that figure. Yesterday we covered translations, which was sliding a figure. If you look at the two examples given here, where I have one figure, let's call this the original and this the image, this the original and this the image. The question is, what happened to the figure in the before and after? Hopefully you'll see that one image is a reflection of the other. Or put another way, the figure flipped when it went from one to the other. And how did it flip? It flipped over a particular line. This line and that line. So, what does it mean when we say we have a reflection? A reflection is a transformation in which a figure is reflected in a line. And the key word we use that is easily understood is flip. The line of reflection is the line in which a figure is reflected. We have to tell you a line so that it gives you some guideline as to how that is going to occur. Line symmetry means when a figure has line symmetry, when a line divides it into two equal parts. So a very simple example given, if I take formal letter A, capital letter A, if I were to draw a line down the middle of it, I'm sorry that it's not very accurate, and folded over that line, A would fold upon itself. You'll see this a lot in nature and science, where, for example, the butterfly has line symmetry. If you drew a line down the body part of the butterfly and fold it, the butterfly would fold on top of each other, or a honeycomb or some other figure like that. Lines of symmetry is the line that divides the figure into two equal parts. Okay, so now we want to go through some examples of reflections. So we look at the first three, and the question is whether there has been a reflection, and if so, what is the line of reflection? Well, hopefully you'll see in the first one the answer is yes, and it was the x-axis that it flipped over. Hopefully you'll see in number two that it's no. All we did was slide the figure down. That's a translation. And in number three, or C, it's yes, and it is the y-axis right there. So now let's undergo, or have a figure undergo, a reflection. Well, if you take a look here, a reflection in the x-axis means the figure will jump over the x-axis. Now, how can you visually see that? Well, the coordinate A is 1, 2, 3 units away from the x-axis. So if I'm going to jump over it, I'm still going to be 3 units away, but just on the other side. B is 1 unit away. B prime is 1 unit away on the other side. If you look at the coordinates, the x-coordinates do not change, but the y-coordinates do, and they change their sign. So the Another way to think of a reflection in the x-axis is I just multiply the y-coordinate by -1. On the other side, a reflection in the y-axis, I now jump over the y-axis. I'm 1, 2, 3, 4 units away on that side. I'm going to end up 4 units away on the other side. 2 units away here. I'm going to be 2 units away on the other side. What changed? My x-coordinates sign changed. Now, let's do an example ourselves. And I want to do it first by the counting, and then we'll do it using the little formula. I'm going to draw the triangle ABC with the coordinates 2, 2 for A, 2, 5 for B, and 4, 1 for C. And I want to reflect it in the x-axis. Well, first thing you should recognize, I'm going to number my my quadrants here. And one suggestion is to highlight the axis or line it's going to reflect over. I'm jumping over this line. Well, if I'm going to jump over the line in red, where am I going to end up? Hopefully you'll see it's in the fourth quadrant. Well, how do I find those new points? A is 2 units away from the x-axis, so it's going to be 2 units on the other side. B is 5, it's going to be 5 on the other side, and C is 1, C is 1 on the other side. That's how I come up with my new or image. As we said with the little formula, if I'm jumping over the x-axis, my y-coordinate sign will change. So I can multiply each y-coordinate by -1. So A prime becomes 2, -2, 2, -5 is B prime, and 4, -1 is C prime. So you have two options here. You can either count how far away from that line of symmetry, or line of reflection, I should say, and figure where it is on the other side, or you can use the little formula, change the signs of one of the coordinates and plot the points afterwards. Now, here's why that counting concept is important. I'm going to draw the quadrilateral ABCD. A is -3, -2. B is -1, -2. C is -3, -5. And D is -1, -5. Now, I'm asking you to reflect it, but not in the x or y axis, but over the line x equals 2. Well, where's the line x equals 2? Well, here is where x is equal to 2 on the x-axis. The line x equals 2 is this vertical line. So hopefully you see ABCD is going to flip over, going in this direction, the line x equals 2. The way to do it is to figure out distance away. B is 1, 2, 3 units away from the blue line. So it's going to be 1, 2, 3 units away on the other side. There's B prime. A is 1, 2, 3, 4, 5 units away. So it's going to be 1, 2, 3, 4, 5 units away on the other side. Same thing for C and D. Or you can see that B and D are aligned and A and C are aligned. And now you can see that when you flip the figure, AB becomes BA. Okay? That's what it means to flip. Now, let's go to the next example. I'm going to take the following triangle, A, which is 2, -2, B, which is 4, -2, and C, which is 4, negative 4. And I want to translate it, or reflect it, I'm sorry, over the line y equals x. Now, right now, you're probably saying, what in the world is that line? Well, y equals x means where is every y coordinate equal to the x coordinate? Well, how about 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. So it is this diagonal line. That is the line y equals x. So now I'm going to take the original ABC and flip it over this line. The first thing, which is very important for you to recognize, is that it's going to end up in the second quadrant. Also, what you should recognize is when you flip this, whatever on the bottom, in this case, is going to go up on the top. Now, it's a very simple formula when you do a flip over or reflection in the line y equals x. What's going to happen is I am going to reverse all my coordinates. So A prime becomes negative 2, 2. B prime becomes negative 2, 4. And C prime becomes negative 4, 4. And when you plot those coordinates, you will see how your figure flipped. The other way to look at it is I can draw a line from A to A prime, from B to B prime, and from C to C prime, straight through. Okay. So, what are our properties of a reflection? Sorry, just reading something here for a moment. Our properties of a reflection are as follows, similar to what we saw yesterday. A reflection maps a line to a line array to array, a segment to a segment, and a point to a point. Next, a reflection preserves lengths or length. And finally, a reflection preserves angle measures. So again, what the 2 and 3 are telling us here is that whatever the length of BC is, B prime C prime is the same length. Whatever the measure of angle A is, the measure of angle A prime is the same. And then the final question is a reflection isometry, meaning is it a rigid motion, rigid change? Yes, length is preserved. So again, to summarize, what we talked about today was a reflection. A reflection is a change in the location of the figure where we flip the figure over a specifically identified line called the line of reflection.